Do you choose the red pill or the blue pill? Do you choose Tarzan or Flash Gordon? Or do you choose Marianne versus Ginger? Hello, everybody. This is Nick DeGiro, Professor of Information Technologies and Computer Science, Lakeland Community College. When it comes to the Matrix, Neo chose the pill to be aware of what the Matrix was, and Cypher decided to choose a pill or go back into the world of the unknown, not knowing about the Matrix. We're talking Tarzan and Flash Gordon. And, what do you prefer? Do you prefer jungle and dealing with animals, or do you prefer more of a sci-fi? I'm not going to talk about Marianne versus Ginger. But in this video, we are going to talk about when to use a list versus a dictionary. So I've created a particular scenario, and I created a series of programs and data files and stuff like that. And throughout the video, I'm going to ask you, what should we use, list or dictionaries? And kind of follow along. Keep a little track of what you think they may be. So let's go up my screen and let's talk about the environment I've created. All right, we are going to use both list and dictionaries in this particular example and see the power of both of them and when we would use either one of them in particular situations. This program does two things. One, it reads in a text file and then determines if that text file is written in English. The second thing it does is it looks at that text file and it organizes and it counts the number of occurrence for each word inside that text file. Now, those are really good examples to potentially use both list and dictionaries in conjunction with each other. So let's take a look at generally what the program does. Let's go down to the bottom of the screen. And the first thing, I went too far, is I have two files of words, right? If the first file, you just call it dictionary.txt, this particular file has over 45,000 English words in it. You'll notice that they're all capitalized, and we'll take that into consideration. And then the other file is also a list of English words, but this one has over 370,000, and this particular file is in all lowercase. So I have two different files kind of doing the same thing. The first one, dictionary, 45,000 words, all in caps. And then words alpha, another just file of all English words, but all in lowercase, and 370,000. So some pretty significant files here. So let's go back to my main program. And the first thing is, if I want to use both of those files, is there a way for me to maintain a list of those files that I can iterate through those lists? Now, think about that. Just two simple files. I want to iterate through the list. Should I use a list or a dictionary? Lock in your answers. Well, the answer right away is I will tell you that is a perfect example of using a list. And here it is. Inside the program, I have a list called Word Files, and that is going to be just going to maintain a grouping of those two files, wordsalpha.txt and dictionary.txt. What I'm going to do is go through two iterations, one iteration for wordsalpha.txt and one iteration for dictionary.txt, and I'm going to create a lookup based upon those files. And if I scroll up, we're going to start with this function right here, load dictionary. What this function does is it opens up those text files and it's going to dump the information in those text files. It is going to build a dictionary. Now, why do we want to build a dictionary? Because one of the files is 45,000 words. The other file is 370,000 words. We don't want to go down a sequential path. What we want to do is basically have a key value structure. So if I give it a word, it will find that word or not find that word far more efficiently. So in this function, open up those files, and we are going to create a dictionary based upon each of those files in each of the iteration. Then what do we do? So great example of building a lookup dictionary. Then the next thing we're going to do is, the English words, as we're building that, we are going to uppercase all of those words. You'll notice I have a constant here. So when we say load dictionary, we're going to do first the word alpha. We're going to load it. We're going to build it. We're going to uppercase it. So that particular dictionary file will have over 370,000 English words associated with it. The next thing we're going to do is we are going to test each of those data files. I have 4 data files. One is Frankenstein, the complete text of Frankenstein, the complete text of War and Peace. Another file I'm just going to call gibberish, and then the 4th file I'm going to call unknown. I don't know what it is. Remember, this program is doing 2 things. One is determining if those files were written in English, and the other thing is it's going to do a count of all the words in those particular files. So we need to iterate through those 4 files. Well, guess what? We're going to iterate using a for loop, and we have that data file or the book files. We're going to put that into a list. Great example of a list. Now let's see what that iteration does. Well, the first thing is it's going to print the file to be determined, so we'll see the file that we're working on. Now this particular line here, where it says text is equal to set message from file book. That is going to open up each of those files in order. It's going to open up the first file, and it's going to take that entire file, and it's going to move all the content of that entire file into a string variable. One big, large string variable. Python accommodates string variables wonderfully, so we're not going to overwhelm it. It's going to be very restrictive based upon my computer. My computer will be able to support it. But if I go to set messages from books, where are you? Okay, set messages. Here's the line. Okay, don't worry about the try and accept. That has to deal with some other things. Sorry for the auto things. I'm only concerned with this is going to open up each of those books in each iteration, and it's going to take the content of each of those books and put those into one big string. And the next thing, okay, right here, the first thing it's going to do is going to test to see if the content of those files are written in English. So I have a function called isEnglish. We see this function right here. Let's take a look at that function. Now this is probably one of I'll say it's the heart of the program, right? Couple things. One, we are going to pass it that string that we created with the big file. We don't have to, but we can pass it a word percentage or letter percentage. We'll talk about those in a second. By default, they are 50 and 85. Just a little typo here, sorry. And what that means is it's a test. It's going to look at those files, and it says if 50% of those words, by default, if 50% of those words appear to be English, then it's an English file. If 85% of the letters in there, then it's probably, if both 50% and 85% of the letters, we're going to assume it's English. Now, a lot of things are going to be happening here in this particular function, but the main purpose of this function is to see if this thing is English based upon any given percentage. The first thing, we're going to build a value called words match, and we're first of all going to get an English count. We're going to multiply that by 100, and if that's greater than or equal to word percentages right here, then that's going to throw a trigger. Now let's take a look at that. So basically word match is a Boolean value, and it's going to say set it true if the English word count times 100, so it's going to be a percentage, we'll see that in a second, is greater than or equal to the word percentage. So let's go up to get English count. And here's our get English count. English count is going to take that one big giant string, and the first thing it's going to do in that string is it's going to remove every non-letters. Don't worry about that function so much. It's then, now this is really cool, it's then going to split that very large string based upon the default, which is split it based upon a character there, and then build a dictionary. It builds a list. That's interesting. So possible words is going to be a list. Sorry for the misspeak there. That's interesting. The next thing it's going to do, if we look down here, it's going to iterate through that list. It's going to iterate through that list, and it's going to test every one of the words. It can do that very sequentially. So the possible words is going to be a sequential list. It's going to go through that list very sequentially, but it's going to compare each word in that list to the dictionary, right? And if there is a dictionary match, we're going to increase the match count. Eventually, when we're done, we're going to replace the total matches divided by the total number of words. So the total number of possible words. Total number of possible words is a list that's going to be derived by just taking that big string, splitting the string. So that string, now that list could be thousands and thousands and thousands of words. Then we're going to go through each and every one of those words to see if those words are inside the dictionary. So here is a great example of a list working with the dictionary to find particular data. We eventually return the percentage. If the percentage of match words divided by possible words is greater than 50%, or where we set it to, then we can say reasonably that file is most likely English. Let's see the next thing we're going to do. All right, so we determined if the words is English, and now we're going to do, remember, it does two things: determine if it's English, and then it's going to do a word count. Well, guess what I have here? I am going to, don't worry about this particular line. This particular line just basically builds the output file for CSV, but I'm going to print this stuff out to the output. Let's look at this line right here. This line says, write to CVS. As we were building all of this stuff, we have this thing called a word count. Word count So get word count starts with a dictionary. So what it's going to do is, again, if we look here, it's going to take that list, or it's going to take that string, convert that string to a list, and then it is going to go through that list very sequentially, and every time it finds a word, it's going to see if it's already inside word count. If it's not, it's going to build a key value pair. The key is going to be the word. The value is going to be the count. If the word is already inside that dictionary, or that counting dictionary, we're just going to increment it. If that word is not inside that dictionary, then we're just going to create it with initial value of 1. So let me repeat this. Again, we're working in conjunction with each other. We have lists working with dictionaries. The list can be just a very, very large sequential file of the file that we read, where we put each word into an individual line. Then we're sequentially going to go down that list, and every time we find a word in that list, we're going to first see if it's already in an existing dictionary. If it is, we're going to increment the count. If it is not, then we're going to create a key value pair, and we're going to do that for every single word in each of those books. So before I run the program, and then eventually we're going to write this out to a CSV file. So let me break this down. We're going to test for if those words are English, and we're going to count each word in each of those books. We're going to use two different dictionary files. One is relatively small, 45,000 words. The other one is relatively big, 370,000 words. And then we are going to write out our data into CSV. Let's run this program. Now we got to give it a little bit of time. There's a lot of words it has to look up. I chose Frankenstein, I chose War and Peace, I chose some other ones. I chose very large dictionary files or word list files, and let's break this down. The first thing, we are using the words alpha text file. That is the file that has 370,000 English words. And we said Frankenstein. Is Frankenstein written in English? And what it says is the percentage of English words that are in Frankenstein, and we found them inside that words alpha dictionary, is 99%. That gives us a pretty good confidence level that that was written in English. The data file just says, okay, if you want to look at the data, and we'll take a look in a second, it's under this particular file. Look at the same thing, War and Peace. 97% of the words in War and Peace appear to be English, so it's the English is set to true, and we have our CSV file. Gibberish, 39%. Remember, we're looking at 50% of the words, 85% of the letters. Gibberish is coming at about 39% words that it found, so it's not quite sure if it's English. And then, because we're using a very large English dictionary or an English word list, the unknown is coming at 57.3%, 32%. It appears to be English, and then we have our CSV file. Now, what if we use a smaller dictionary, a smaller word list? This file only has 45,000 English word. So we're probably going to get smaller values on the percentage of English words because there's just less words to look up. Again, Frankenstein, 73.88% of the words were in that word list, English word list, so that's still true. War and Peace, the same thing. War and Peace, 76.48 words in there. So we're pretty confident that both Frankenstein and War and Peace in the text that I have were probably written in English. But then we get into gibberish. Gibberish, with a smaller dictionary, is only finding 7.2% of the words in that smaller dictionary. Good chance this is not, according to the dictionary words, it's not written in English. And then finally, the unknown, so only about 12.14% are in that list of English, the very small list of English words. And then we have the CSV file. So we kind of get a better understanding that maybe these files, those two files, may not be in English. If we use a very large list of English words, we get a higher percentage of hits. We use a smaller list of English words, then we get a smaller list. So let's take a look at those words. Let me shrink these down. And we are going to start with, let's take a look at, we know Frankenstein and War and Peace, but let's take a look at Frankenstein real quickly. It says, well, that's the number of characters, wrong file. Frankenstein word count, there are 4,364 thes in Frankenstein, 3,040 ands. If we scroll all the way down, there's only, it looks like there's only one occurrence of newsletter, one occurrence of subscribe. So these are all the words that only occur one place inside Frankenstein. If I look inside gibberish, gibberish is using just some placeholder words. They're not even real words. I just used another program to generate these words. So gibberish, 398 variations of the word integer inside gibberish. War and Peace, 34,577 occurrences of the in War and Peace. So you can kind of see where this is going. Now we can kind of look at this stuff with a little bit of an eye towards data analytics. So let's review this program. Program does two things. It uses two different word list files. One has 45,000 words. The other has 370,000 words. I took those and I built a Python dictionary inside the Python program so I can find those words more efficiently. I then looked at four individual files to determine if those files were English. So it took those files, dumped each of those files into a string, one big giant string, took that string, split it up into a giant list of individual words, and then went through that entire list building a dictionary based upon the counts associated with those words. Again, the list and dictionaries working together. I did that again with two list files, two word list files, and 4 books, and that gave me percentages. The percentages basically told me are those particular files written in English. I can use this program for other things. Let's say I'm de-encrypting code and I want to make sure that the code is in English. Maybe I can run this through so it would look for the de-encryption based upon English. But what's more important, not so much what the program did, but how it did it. It used a combination of both lists and dictionaries. Let's wrap some things up. We did that in several approaches. One, we had a bunch of files, text files, that had a listing of words, right? And we took those words, excuse me, one of those files had 45,000 words, the other one had 370,000. I took those and I converted those files inside the program. I created a dictionary file that would allow me to quickly look up words and keep a count on those. In some situations, we also then took the files that we were curious about, Frankenstein, War and Peace, Gibberish, and Unknown, reread those in as a list. Why? Because it was just sequential. We didn't care about anything indexing, so we read those in as a list because it'd be more efficient to read those sequentially. And as we read those, we did a count. The count was stored in another dictionary file that says, okay, the word the occurred 15,000 times, and it just went through that. So we then did some comparisons. We divided the total words found inside a dictionary versus the total words, and we came up with a percentage. And we said, okay, the total word percentage, total words in the dictionary, the ones that were percentages, 50%, and we're safe with it. Somewhat of a complex program, I will say that, but what was more important about this program is not the internal workings of this program. There's some advanced, not too advanced features in here, but if you're interested, there's about how to read text files. There was concerns about, I didn't show it to you, concerns about getting to the end of the file, concerned about maybe potentially dividing by 0 where you have a count, but there's no legitimate words, and those were all taken into consideration. I put those inside function, but the most important takeaway of this particular program isn't really the understanding of the program, but at certain times when we needed to do lookups, the most efficient way to do a lookup was still by using a dictionary. When we had a key and we were looking for a value, or when we were storing information based upon an unknown number of occurrences, the word the. We had to keep a dictionary with the key the and kept incrementing every time we ran into the word the. And then we put that into a CS file. Other situations, we used a list because we didn't have to worry about the index. When we're reading in an entire text file and we're just starting from the top and going to the bottom, that screams list. So red pill, blue pill, Flash Gordon versus Tarzan, Ginger versus Mary Ann. It really does matter on what are you trying to accomplish? What are you doing? What is your overall objective? It is not do everything in list or do everything in dictionary. It is, there are times to use a dictionary and then there's a time to do a list. Now, with that being said, let's go learn something.